Now let's look at question number 8 of the BHSEC 2024 MCQ Maths. In this question, we are given with two complex numbers, set 1, 2 plus 3i, and set 2, which is 1 minus 4i. And the question asks us to find the amplitude of the complex number z1 times z2. Now first and foremost, let's find the complex number z1 times z2. So we just multiply 2 plus 3i times 1 minus 4i. From here it's just simple algebra, so we multiply 2 on both these elements. So 2 minus 8i plus 3i minus 12i squared. And since we know that I square is -1, we can substitute -1 here. So the equation will be like 2 plus 12 minus 8i plus 3i, and we get 14 minus 5i as the complex number for z1 times z2. Now to find the amplitude, first let's find the theta. So theta is tan inverse of modulus b by a. So in this case, b is -5 and a is 14. So we basically substitute it here. So tan inverse -1 over -5 over 14. And since there's modulus, we can directly ignore the negative sign. So we get approximately 19.65 degree. Now we must never forget the final step, which is to find which quadrant does this final angle lie, or sorry, which quadrant does this complex number z1 times z2 lie. So in the quadrant we have 1, 2, 3, 4 quadrants, and since this is basically the coordinates of the complex number. So we have x 14, y is -5, so x positive and y is negative, so the complex number will lie on the fourth quadrant. And in the fourth quadrant, the final theta or the amplitude is basically negative theta. So the amplitude of z1 times z2 is negative 19.65, which is your option B. Hello everyone. Now let's look at question number 9 of the BHSEC 2024 MCQ Maths. Now the question states that a beetle is crawling on the ground in time t seconds and is given by the distance formula 2t minus 2 cubed plus 5t. And the question asks us to find the minimum velocity. I repeat, the question asks us to find the minimum velocity and not the distance. So first of all, we must find the velocity. Now we already know that velocity is basically the derivative of derivative of distance with respect to time. So let's first derive this. So velocity equals to, whenever we derive, we start from outer to inner. So 3 first. So we get 6 t minus 2. So n minus 1 is 2 times, now inside the bracket, now the coefficient of t is 1 and the constant is 0, so basically times 1 plus the coefficient of t is 5, so we get 5. Now whenever we find the maximum or minimum, we must find the derivative of the function we are finding. So now we must find the derivative of velocity. So the first order derivative is again from outer to inner. So 2, so 12 and t minus 2 and 1, and minus 1, 1, and again inside the bracket we get 1, and since 5 is a constant, it is 0. Now let's find the time at point, or like at v prime, or acceleration 0. Now we use this acceleration 0 at point 0 because at maximum or minimum the slope of the gradient is always 0. So the slope of the tangent is always 0. So at this point the slope is neither increasing or nor decreasing. So this point is the maximum or minimum point. So again, we substitute instead of v prime or acceleration. So 0 equals 2. Again, let's multiply this inside the bracket. So we get 12t minus 24. And after calculating it, we get 2. So velocity is either maximum or minimum at point 2, or at time 2. Now, we know that when finding maximum or minimum, we must find the second order derivative or more depending on the question. So let's find the second order derivative of v velocity. So now v double prime equals to, so first v prime is 12t minus 24, so basically 24 is a constant, so it becomes 0 and we get 12. Now since 12 is positive, we know that this point is minimum. So this point is minimum. So basically velocity is minimum at time t 2 seconds, which is your option D. Hello everyone, now let's look at question number 10 of the Big C 2024 MCQ Maths. In this question, we are given with a figure consisting of a plane and two coordinates. We have point A, which lies on the coordinates -4, -3, and 3, and we have point B, which lies on the coordinates 2, 0, and -3. And we are asked to find the coordinates of point C, which lies on the YZ plane. Now this question uses the concept of both plane as well as points and its coordinates. So first and foremost, let's assume the ratio in which the plane divides this line segment to be k:1. Now we need to use the section or division formula. So let's write down the section and division formula. We have m1, which is just the first ratio, times x2 plus m2 times x1 over m1 plus m2. Similarly for y, we have m1 times y2 plus m2 times y1 over m1 plus m2. And again, similarly for z, we have m1 times z2 plus m2 times z1 over m1 plus m2. Now we know that in a YZ plane, the x coordinate is always 0. And since the c coordinate lies on the YZ plane, the x coordinate of this c is 0. So since we know the coordinate of x, let's assume, or let's substitute k and 1 in this equation. So m1 is first ratio k, so k times x2, which is 2, so plus, now the second ratio 1 times -4, so -4 over k plus 1, and since we already know the x coordinate, it is 0, so we get 2k minus 4 equals to 0, which is basically k equals to 2. Now since we have k, we can directly substitute k in each of this equation and find our answer and find our coordinates for y and z. So let's substitute it again. This is for x. Now for y, we have m1, which is k, so 2 times y2 is 0, so 0, 2 times 0, plus m2 is again 1 times y1 is -3, divided by 2 plus 1, which equals to -3 over 3. So y is equals to -1. Now for for z, let's substitute k in this equation, so in this formula. So we have k is 2 times z2 is -3, plus m2 again 1 times z1 is 3 over 2 plus 1, 3. So we have -6 plus 3, which is -3 by 3, and the final answer is z is -1. So the coordinates of point C is 0, x coordinate 0, -1, -1, which is your option A.
So for question 11 of the MCQ, we have this question. In a fair, Karma and Sonam threw 6 identical darts at a target 10 meters away. The following represents the probability associated between them. So we have the probability of, firstly, karma or Sonam not hitting the target. So for our convenience, we'll take event A as karma hitting the target and event B as Sonam hitting the target. So we have karma or Sonam, so that is union. B, but that is not happening, as 1/6, and we have the probability of karma and Sonam hitting the target, so that is intersection. B is equals to 1/4, and we also have the probability of karma not hitting the target, that is 1/4 as well. So what we are asked here is, we are asked to evaluate the dependence and mutual exclusivity of the two events. So firstly, you can check for the dependence. If event A and B are independent, then probability of A intersection B is equals to probability of A times probability of B. So we'll check for this condition. So firstly, we can find probability of A, then we need to find the probability of B. Probability of A can be directly found from here, because the sum of an event, the sum of the probability of an event happening plus the probability of that event not happening is equals to 1. So we can directly find the probability of A happening by subtracting 1/4 from 1. That will give us 3/4. Similarly, we can do for this one. So probability of A union B will be 5/6. So to find the probability of B, what we can do is, we can use the formula for the probability of A union B. So the probability of A union B is equals to probability of A plus probability of B plus probability of A intersection B. So that is equals to, we have 5/6 over here, 1/4 over here, and that is the unknown probability of B plus the probability of A intersection B is 1/4. So we have probability of B is equals to 5/6 minus 2/4. That will give us 1/3 if we subtract them and simplify them to the lowest term. So now we check for this condition. So we have probability of A intersection B as 1/4 is equals to probability of A, which we have as 3/4 times 1/3. So we just cancel that out. So 1/4 is equals to 1/4. So this condition holds true for this set of given events. So event A, that is karma hitting the target, and event B, that is Sonam hitting the target, are independent of each other, and they are not mutually exclusive as well, because mutually exclusive means that two events can't happen at the same time, and here the two events, probability, that is karma hitting the target and Sonam hitting the target, can happen at the same time, because we are given with probability of karma and Sonam hitting the target. So we can conclude that the probability of karma and Sonam hitting the target are independent and are not mutually exclusive. Sorry, not the probability. The events A and B, that is karma hitting the target and Sonam hitting the target, are independent of each other and are not mutually exclusive. So that is option D. So for question 12 of the MCQ, we are asked to calculate the angles made by the normal to the plane x minus 2y plus 2z minus 4 equals to 0 with the axis. So we're given with the equation of the plane. So that is x minus 2y plus 2z minus 4 equals to 0. So we have a given plane, and that given plane has a normal. So we're asked to calculate what angles are made by this normal to the three axes. So if we take a simple diagrammatic representation of the three axes, so we can have the normal somewhat like this. So we are asked to calculate the angles made by this normal to the three axes. So we can have x over here, y over here, and z over here. So let's denote this as alpha, beta, and gamma. So we are basically asked to calculate alpha, beta, and gamma, and we can do this using a formula. So the general formula of a plane is in the form of ax plus by plus cz plus d equals to 0. And to calculate the angles, we need the value of a, b, and c. So a here is 1, b is equals to -2, c is equals to 2, and d is equals to -4. So the formula goes as follows. Alpha is equals to a divided by root of a square plus b square plus c square. Beta is equals to b divided by root of, similar to this, a square plus b square plus c square, and gamma is equals to c divided by root of a square plus b square plus c square. Sorry, I forgot to include cos inverse. So there's cos inverse over here in all three equations. So don't forget to include this. Have cos inverse. Because we have cos alpha over here, cos beta over here, cos gamma will be equal to this equation. So if we take this to the other side, that will be cos inverse this equation. So for alpha, that is equals to cos inverse. We'll have a as 1 divided by root of a square plus b square plus c square. That will be 2 plus 2 square, so 4 plus 4 plus 1, that will be 9. Root of 9 will give us 3. And beta will be cos inverse of negative 2 by 3, and gamma will be cos inverse of 2 by 3. So that will be option C in your question.
Question 13 here tells us two judges were appointed to grade 6 areas in SUPW. Find the x if the difference between the assigned ranks were as given below. So the classes from A to F and the rank difference for being -1 for A, an unknown rank for B, 2.5 for C, 3.5 for D, -2.5 for E, and -1.5 for F. This is a straightforward statistic question based on Spearman's rank correlation. Here, what we have is that the rank difference for two judges, given judges 1 and judges 2, will always be 0. The rank difference will always be 0 in a no bias situation. That is, if perfectly correlated and or equally opposite. So this situation is one of these, because the judges will not have bias when judging the SUPW areas. Therefore, the options given to us here are -1 for class A, x for class B, 2.5 for C, 3.5 for D, -2.5 for E, and -1.5 for F. Firstly, we'll find the sum of ranks, the rank differences. That is, -1 plus x plus 2.5 plus 3.5 plus -2.5 plus -1.5. And since we said so before, in a no bias situation, the sum of rank difference shall always be 0. Solving for the rest, leaving out x, we have 2.5 and -2.5 cancelling out each other, 3.5 minus 1.5 giving us 2, and 2 minus 1 gives us x plus 1 equals to 0. And therefore, we get x equals to -1 and our answer choice being C. Question 14 here tells us that athlete Mike Powell from the United States has a world record of 9 meters in men's long jump. He initially accelerates for a few meters, then takes a jump once he gains momentum. If the locus of his jump is given by y equals to 9x minus x squared, what is the area under the curve and the horizontal ground? Let's illustrate this question with what is given to us. So we have athlete Mike Powell who has a high jump long record of 9 meters. And we are supposed to find the area under the curve, meaning how much he had jumped for, from a lower limit of 0 to the upper limit of 9. We have a given function that says y equals to 9x minus x squared. Integrating this y function in order to get the area under this curve, we have integrating 9x minus x squared from a lower limit of 0 to upper limit of 9 with respect to x. Solving for this, we get 9x squared divided by 2. How? When we integrate, when we integrate a function, we firstly raise the power of the x function by 1. in this case we have x as 1, so n x to the power 1 plus 1 divided by the sum of the power, which is 2. So now we have 9x squared divided by 2 minus x cubed divided by 3 from a lower limit of 0 to an upper limit of 9. Solving for the upper limit, we get 9 squared is 81. Multiply that by 9, we get 729. Divided by 2 minus 9 cubed as 729. Divide by 3. This is for the upper limit. Solving for the lower limit, you put in 0 into x function, you will get 0 here. So subtract that, the upper limit minus the lower limit, you will get 0 minus, you put a 0 cube, divide that by 3, you still get a 0 here. So the lower limit is disregarded. Next up, we get 364.5 minus 729 divided by 3, we get 243. Subtracting these, we get 121.5. Hence, therefore, our answer is option A.